All right, hey Remington, we are on, I don't even know what this lesson is, 5, 6. Here's a homework assignment, 5, 6, and then 8 through 14. 8 through 14 is all, not evens. 8 through 14 is all, sorry.
Yeah, Megan, thanks for not helping.
8 through 14, all. So there's that, okay? No proofs though, so that's kind of exciting. Here we go on section, this is isosceles and equilateral triangles, okay? So let's just summarize what we know about isosceles. What does that mean? What is an isosceles triangle? Two equal sides. I'm gonna write that down. Okay. What about an equilateral triangle? What's equilateral?
All equal sides.
All equal sides. I'm chuckling at, who is it, Brian? All equal sides. Okay. Now, all equal sides. I'm gonna draw you a picture of two triangles that have all equal sides. One of them is bigger than the other, right? And let's say all of these sides are 2s, 2, 2, 2. And let's say all of these sides are 5s, 5, 5, 5. Okay? Those both are equilateral triangles, right? Now, the rule with equilateral triangles about the angles is that, if I'm looking at like this equilateral triangle here, all of those angles will have to be the same as well. Yeah? Okay, what do all the angles add up to be? 180, right? So what's each one of them? 60. 180 divided by 3 is 60. So this guy's 60, this guy's 60, and this guy's 60. Okay? Now, question. Because this triangle is equilateral also and larger than the smaller one, right? Does that mean like these are like 100 degrees?
No.
And 100 degrees and 100 degrees? What are they? They're all still 60s. So even though the other one is bigger, the angle measures stay the same. The sides will get bigger, but the angle measures will stay 60s all the way around, right? So that is true for an equilateral triangle. Okay, let's talk about the one other one. What's it called if none of the sides are the same? Scalene. It's a weird word. Scalene equals no equal sides. Okay, that's what it is. Just as a vocabulary word, so you know that. Okay, no equal sides is a scalene triangle. All right. All right, moving on. Let's go to this isosceles triangle. They will use some terminology for an isosceles triangle, and they will say the two that match each other or two that are the same are called legs. So a leg and a leg. Okay, the base is the third side. Now, the base does not necessarily mean the bottom. For example, this is an isosceles triangle where these two match. Those are called the legs, right? Leg, leg. But this guy is the base and the base is not the bottom. Make sense? Base doesn't mean bottom. Base means the one that's not the leg, basically. Okay? Now, angle 2 and angle 3, they do not have them labeled on the diagram, but they talk about them later on. These two angles are called base angles, right? They're the angles that touch the base, angle 2 and angle 3. And the base angles are the ones that are equal to each other, right? Angle 2 and angle 3 will be the same measure. So if this is 50 degrees, then this will also be 50 degrees. Make sense? Okay, those will be the same. Angle 1 up here at the top is called a vertex angle. Now, if those two angles are 50 degrees, can I figure out what angle 1 is? Yeah, what will it be? 80. They all add up to be 180, right? So 50 and 50, that's 100. And then the top one is 80. But this is called the vertex. These are called my base angles because they're touching the base. Got it? All right, so if this is angle 1, this is angle 2, and this is angle 3, which one is the vertex for that guy? 3, and the base angles would be these two, right? Okay, now, here's a diagram down here. This is the very bottom of that page. Last thing before we actually do an example. Well, second to last thing. Okay? In this diagram, it tells me that this side is the same as this one. So right now I know it's an isosceles triangle. This is the magic thing that happens. You take this side and you crisscross him to go to angle 2. And you take this side and you crisscross him to go to angle 1. And if this side is the same as this one, the crisscrossy angles match each other as well. So if the sides are the same, the angles will be exactly the same measure, right? So if this side is 8 inches and this side is 8 inches and they tell me angle 1 is 70 degrees, angle 2 will also have to be 70 degrees because the sides match, so the angles match. Make sense? Got it? Now, the opposite is also true. So in this diagram, this is the top of the next page. In this diagram, they tell me that angle 1 is the same measure as angle 2. So let's say angle 1 is 80 degrees and angle 2 is also 80 degrees. Okay? The same thing is also true. If I crisscross them to figure out the sides, this side will be the same length as this side. And that is true for isosceles triangles, right? If the base angles match, the sides match. If the sides match, the base angles match. Make sense? So it goes one way or it goes the other. If I'm given that the sides are the same, that means the angles are the same. If I'm given that the angles are the same, the opposite sides are the same. Got it? Okay, so I can crisscross, like I call that like a crisscrossy thing, okay? So isosceles triangles, that's the way that they work. Let's do an example, and I'm not going to do the proof. We're going to skip to example 2, which is the top of the next page. All right, example 2. This is kind of a pain in the butt. So no proofs, but this one's kind of a pain in the butt. It wants us to find the measure of all the angles, angle B and angle C. Now, before I do that, I know that this is 70. That's all I'm given, right? I need to find what angle B and angle C is. We don't know what kind of triangle this is. It looks like it might be isosceles, but we have to figure that out. And we only know by finding the length of what each of those sides is. The distance formula. So A, I'm going to write out the coordinates, is at 0, 3. B right here is at 4, -2. And this guy is at -4, -2. Okay? Now, I don't necessarily have to do the distance formula for the bottom right here. I could just count that. How far are those two apart from each other? How far is that? 8? So that's 8 units. I could just count that, right? But for the other ones, we have to do the distance formula. So I'm going to do a distance here. And I'm going to do a distance here. Okay. All right. Now I look at my coordinates. So -4, -2, and 0, 3. How far apart is -4 and 0? 4. And -2 and 3 is 5. Okay. 4 squared is 16. 5 squared is 25. The square root of 16 and 25 make 41. Okay, we'll just call it the square root of 41 because it doesn't come out nicely. So we'll just leave them as the square root of 41. Okay. The other side, I'm looking at 0, 3, and 4, -2. How far apart are 0 and 4? 4, 3, and -2. 5, that's another 16 and 25, which means that guy is the square root of 41. So I know right now what kind of triangle are we dealing with? Isosceles. Okay, so we know that this side and this side, I'm writing really big, those two sides are the same. And I can do the little crisscrossy thing, which means that if those two sides are the same, that those two angles that I just drew arrows to are also the same. So this angle is the same as this one. All right, now how can I find what those two are?
180 minus 70.
I know the top one is 70, right? Yep, so Megan says 180 minus 70, okay, is how much? 110, okay, then what?
And then divide by 2.
Now we divide by 2, perfect. And that is like 55.
Yeah.
So each one of those angles is going to be 55. Okay, we can't jump straight to that until we know it's a perfect isosceles triangle. Got it? So find the measure of angle B and angle C. They are both 55 degrees. Got it? That was a lot of mess to go for that one. But you got two problems like that. I think it's like 5 and 6 are those that are kind of like that. Okay? All right, here we go. A couple more, maybe one more. Two more problems. Okay. At the bottom of that same page, it talks about equilateral triangles, and I'm just going to identify this. We've already said this. If a triangle is equilateral, the word lateral means sides. So equal sides, equilateral, equal sides. That's what equilateral means. It is equilateral if and only if it is equal angular. Angular means angles. Equal means equal. So if it has equal sides, it also has equal angles. Got it? So if my equilateral triangle, all those sides are the same, that means all the angles have to be the same as well, right? We've said that. That just only makes sense. Then they go one step further in the next one and they say, okay, if it's equilateral and equal angular, then all of the angles have to be 60s. They have to be, right? Because they have to add up to 180, so all of them are going to be 60s. Is that pretty basic? Do I need to go over that again? Okay, 60, 60, 60. Good. Okay, Let's do an example. Example 3, next page. They want us to find the measure of angle J. All right. Now, I don't know if this is an isosceles triangle, an equilateral triangle, or a scalene triangle, okay? So let's go off of things that we know. The only thing that I know right here is that this is 12 and this is 12. So these two are technically matching each other, right? So at this point, I have that this triangle is an isosceles triangle, true? Like those two sides match each other. But if
60
if those two sides match each other, then I can do the crisscrossy thing, right? Which means that that's 60. This one has to also be 60, right? True? Which means the top one has to be 60 as well in order for them to add up to be 180, true? So now it's not isosceles anymore. Now it's equilateral, and I can say that the third side is the same. So this one is going to be 12 as well. So we start off knowing he's isosceles, and then we're like, wait a second, the angles mean he has to actually be equilateral, true? So they want us to find the measure of angle J, 60 degrees. Got it? Does that make sense? Like our thought process through that? Okay, we can't just jump straight to it being 60, because that's not necessarily true until we look at all the further information. All right, let's go to example 4 and then we'll be done. Example 4, here we go. All right, I'm going to rewrite this because I don't know if you guys can see this. This is 4y minus 2. And this is 2y plus 2. And this angle right here is 6x plus 6. And this top angle is 60. And the only other thing that I know is that there's a tick mark here. And can you see a tick mark here? Do you see the tick marks?
That means it's an equilateral if it's 60. Right?
Yeah. So do you guys see those tick marks on your diagram? Okay. So if I look at the crisscrossy thing, right now, I know he's isosceles, true? Because it has those two sides are the same. But if I crisscross, and if that's 60, then this has to also be 60 right here, right? But then that means this guy has to be 60 as well, right? Okay, so let's look at this right here. 6x plus 6, we said he has to be equal to 60, right? That's what that bottom angle is. 6x plus 6 has to be 60 because he has to match this angle up here, right? So we use that to solve for x. Okay, what shall we do first? Minus 6. 6x equals 54, and then divide by 6. And that is 9. 9. X is 9. Okay? All right, now for y's. I have 4y minus 2 is here, and 2y plus 2 is there. And I don't, right now, with the tick marks, the only thing I know is that this guy matches this guy, right? But, does he also match that one over there? Because he's an equilateral triangle. So I can say that those two things are equal. 4y minus 2 is equal to 2y plus 2 because he's equilateral, right? After we do all the loop-de-doo stuff, we know that they're the same. So, let's subtract 2y. And can I add this to it at the same time? Okay, so 4 over here and 2y over here. Y equals 2. Yeah? And let's see what they had us find. Find the value of each variable. Done. Y is 2, x is 9. Good? Okay, that's it. Isosceles equilateral triangles. There's your homework. Good? All right, that is all. Goodbye, Remy.